This is a tutorial video from the FM synthesis tutorial series for the famous DX7 E.PIANO 1 and FullTines. In this tutorial, we will start making improvements to the famous FullTines patch. Although the FullTines patch has a sharper attack tone, we can look into giving it more solid attack. Remember what we did for the E.PIANO patch? We gave it a solid attack tone by having an additional modulator. That means that we need to look into the algorithm interchangeability. For this exercise, we will follow how we improve the E.PIANO 1 patch. My choice of algorithm for this exercise is 13. Use operators 5 and 6 as modulator that are directly linked to operator 3. We will use operator 5 for a hammer tone. We will use operator 6 for a soft and sawtooth tone using its feedback loop. We can change algorithm by going to the algorithm screen. Press the edit button and press button 7. You can use the slider or data entry button to select algorithm 13. After completed, when you press a key, it has too much modulation, as operator 5 output level is set at 99. So, what happened? We basically increased the number of modulators. Now it's 4 instead of 3 modulators and 3 carriers with algorithm 5. This means that you have more flexibility in FM sound design. Now, we will look into oscillator. Press button 19 and use operator select button to select operator 5. You can turn off operator 6, but make sure to keep operator 3 on. Press button 17 and you will see operator 5 using frequency ratio. We will change it to fixed frequency by press +1 button. Press button 18 and you will see that the fixed frequency is set at 10 Hz. We will increase this to 100 Hz by pressing +1 button. Press button 19 and adjust fine to 158.5 Hz. Once completed, let's hear the sound. At the moment, you are only hearing its inharmonic tone, sounding like a noise, as operator 5 envelope is not set for a short decay type. We will adjust operator 5 envelope so that it actually sounds like a hammer tone. Press buttons 21 and 22 and use operator select button to see how operator 5 envelope is set. At the moment, operator 5 has a 2 decay type envelope with a very long decay. So, we will change it to 1 decay type envelope with a very short decay. We will apply what we've learned from the tube bells improvement. First, we will change rate 2 from 20 to 78, so that rate 2 has faster speed and very short decay. Then we will set level 2 from 95 to 0, so that it has only 1 decay. Once completed, Press a key and let's hear hammer tone. Now, it actually sounds like the hammer tone. Let's turn on all operators and hear the new FullTines. We can summarize what we've done so far. We changed the algorithm from 5 to 13. We changed operator 5 to a fixed frequency of 158.5 Hz. We changed operator 5 envelope from a longer decay envelope to a hammer tone short envelope. Now, you will also notice that something else has changed. A chorusing effect is not as smooth as before. There seems to be too much modulation for a decay tone. So, what do we need to do next? We will make changes to a chorusing effect so it becomes smoother again. As a beautiful and smooth chorusing effect is must for great electric piano sound, we will start with detune. Before adjusting detune, let's revise how the overall chorusing effect is created. It is created by operators 1, 3, 4, and 6. Operators 1 and 3 are carriers. Operators 4 and 6 are modulators. We will adjust those operators to find the sweet spot. As the DX7 has 6 operators, it can get really tricky and complex to adjust detune for all operators. So, we will start with focusing on carrier operators only. We will adjust operators 1 and 3 first. Turn only operators 1 and 3 on. At the moment, operator 1 is -7 and operator 3 is 0. This creates a slow chorusing effect. We will make the chorusing effect faster. Increase operator 3 detune by 1 increment. When you reach +5, the chorusing effect gets very fast. Then you can try decrease operators 1 detune by 1 increment. At -4, it seems just right. In this exercise, what we did was to balance detune for operators 1 and 3. Instead of one operator having an extreme value like -7, we adjusted 2 operators with medium detune level opposing each other. So, we will set operator 1 detune to -4 and operator 3 detune to +5. Now, we will move to modulator operators 4 and 6. Turn operators 1, 3, 4, and 6 only. When we play the sound, it needs an adjustment. It has too much wow or modulation. Select operator 6. At the moment, it is set at +4, so we will keep it as is. Select operator 4. It is set at 0. We will adjust its detune by 1 increment. Try go up and down. When you set it to +4, the modulation is gone. we will set it at +4. Let's turn on all operators and hear the sound that we've just made. What do you notice? The overall chorusing effect is much better. It has a solid attack tone, but hammer tone is too prominent without expressiveness. There seems too much decay tone. We will go through the list of priority parameters, which are keyboard rate scaling, output level, and key velocity sensitivity, and adjust accordingly. Press button 26 and use operator select button to go through each operator. The hammer tone generated by operator 5 is set at 4. This is too high for the hammer tone. You only need a minimum shortening of the hammer tone at higher notes. So we will adjust it to 1. Also for carrier operators 1 and 3, they are set at 4. We will change them to 3 so that those carrier operators 1 and 3 can have longer envelopes. What this does is to make the overall chorusing effect last longer. Now we will change output level. Press button 27 and use operator select button to go through each operator. You will notice that carrier operators 1 and 3 are set at 95, which is slightly lower. So we will put them to 99. As we adjusted operator 1 output level to 99, operator 2 is producing too much sharp metallic tone. We will reduce operator 2 output level slightly to 78. For operator 4, it has too much modulation as it is set at 89. Try change it from 85, 75, and 65. When set at 65, it has soft decay tone, so we will set at 65. For operator 5, like what we did in the tube bells improvement, we will adjust it to 90. For operator 6, as FullTines has a more prominent sawtooth decay tone, we will keep it at 85. We will go through the final step, key velocity sensitivity, to give better expressiveness to the new FullTines patch. Press button 28 and use operator select button to go through each operator. As operator 5 is set at 1, we will change it to 3, giving better expressiveness with the hammer tone. For operators 1, 2, 3, we will change them to 2, 7, 2, This will give a better chorusing effect and expressiveness. Let's hear the sound by turning on all operators. Now, we have the new FullTines patch. So, let's revise what we've done. We changed the algorithm from 5 to 13. We created a hammer tone using operator 5 by adjusting its fixed frequency and envelope generator. We adjusted detune to give a smooth chorusing effect. We adjusted keyboard rate scaling for operators 1, 2, 3, 4, and 5. We adjusted output level to have a balance of sharp and solid attack with a soft decay tone. We set key velocity sensitivity for operators 1, 2, 3, and 5, giving expressiveness to the new FullTines patch. So, please enjoy playing the new FullTines patch. I hope you learned a lot by joining me on this FM synthesis journey. Compared to the tube bells, the DX7 electric piano patches are a bit more complex. Why is it complex? It has more parts to the electric piano patches. First, you have a metallic attack tone. Then, you have a hammer tone. Finally, you have a decay tone. Putting together these three parts to make a great electric piano patch is a challenge. The key is to find a sweet spot for balancing those three parts. The first part is a hammer tone. This is quite straightforward. You need to change its frequency to fix, then adjust its envelope. The second part is a decay tone. Because the original electric piano patches use algorithm 5 with 3 independent towers, it is much easier to create a suitable decay tone. However, as we sacrifice the extra tower for an extra modulator operator, remember we moved from algorithm 5 to 13 from 3 carriers and 3 modulators to 2 carriers and 4 modulators. It becomes a bit tricky. As operators 4 and 6 are used for creating a decay tone for the original patches, we use them to do the same, except that we only have one shared carrier operator 3, instead of 2 independent carrier operators for the original patches. This means that we need to reduce one of operator's output level so that there isn't too much modulation going into the single shared carrier operator 3. The most challenging thing with the electric piano patches improvement is recreating a smooth chorusing effect using only 2 carrier operators instead of 3 carrier operators of the original patches. In this case, we are not only adjusting detune, but keyboard rate scaling and output level to get as smooth chorusing as possible with just 2 carrier operators. So once we adjusted everything, we get new and improved electric piano patches with sharper and solid attack and still retain smooth chorusing effect. So, congratulations to you all for joining me to this journey to the end. Thank you.